So this is video homework assignment number 2 for chapter 11. In the question, we are asked to determine the difference between a copper sulfate and a copper sulfate pentahydrate based on freezing point depression and the Van't Hoff factor. So we are going to be using the freezing point depression equation, which is delta T times I, your Van't Hoff factor, times your cryoscopic freezing constant, times molality. Molality is moles of solute over kilograms of solvent, and we don't know that yet. We do know the Van't Hoff factor of both of these molecules because CuSO4 is going to dissociate into two ions, a Cu2 plus and an SO4 2 minus. Two ions dissolving in a solution. We're going to say our solvent is water, so that would dissociate and get you a Van't Hoff factor of 2. Looking over at our copper sulfate pentahydrate, our Van't Hoff factor is also going to be 2 because this dissociates into the same ions, and since we're using water as our solvent, this does not dissociate into anything, it just goes into solution. Now we need to find our molality, and in order to do that, we need to get kilograms of solvent over moles of solute. We are going to use 10 grams of H2O, and you do the conversion factor of 1 kilograms equals 1,000 grams. That gets you 0.1 kilograms of our solvent. Now we need to get moles of solute. So we take 1 gram of CuSO4 times that by the molar mass conversion ratio of 1 mole equals 159.609 grams. And that gets you the 0.006265 moles of CuSO4. To get the molality, you then divide that by the kilograms of solvent, which we found here, and that equals our molality of 0.06265 moles per kilogram. Then we're going to plug that into our freezing point depression equation. So we have 2 for our Van't Hoff factor. The cryoscopic constant for water is 1.86 degrees Celsius kilograms over mole, and then we plug in the molality that we found here. Our moles and our kilograms are going to cancel out, leaving us in degrees Celsius. That equals 0.23 degrees Celsius. So we know that if our unknown is CuSO4, it will have a freezing point depression of 0.23. We do a similar process over here, but instead of using the molar mass for just copper sulfate, we have to add the pentahydrate in, which gets us a molar mass of 249.70 grams. That gets us into 0.0040 moles. And then we do the same thing where we get molality by dividing moles per kilogram. Gets us a molality of 0.04 moles per kilogram. Plug that into the same equation, and that gets us a freezing point depression of 0.1